So this video is going to be part 4 of our convergence and divergence of series problems. Okay, so we want to prove if this series is going to be convergent or divergent. We have the series, the sum from n equals 1 to infinity of negative 1 to the n times n over the natural log of n. Now, a lot of people are going to look at this and just immediately try the alternating series test. Okay, but as you're about to see, there's going to be an easier way to do this. Okay, if we just do our step-by-step checklist, we have diclar up here. We start off with that test for divergence. Okay, and we start off with that test for divergence. We take the limit as n approaches infinity of our a sub n. Right, that is right up here. We have that negative 1 to the n times n over the natural log of n. Alright, now, as n approaches infinity, well, this negative 1 to the n, that's not really going to matter here, okay? So we're just going to get rid of that. Alright, and now we have n times the natural log of n left over, okay? And you can see that n is larger than natural log of n, right? If you have something like, if you plug in n equals 2, okay? You have 2 over the natural log of 2. The natural log of 2 is a small decimal, right? And, well, 2 is bigger than that. So, as n approaches infinity, this is going to, the numerator, is going to get larger and larger at a faster rate, okay? So, this limit equals infinity, which is not going to equal 0. Therefore, this series is going to be divergent by the test for divergence. So just to kind of recap, you could have done you could have tried the alternating series test first. Not sure if it would have worked or not, but the fact is that you need to go through your step-by-step first. You need to go through, diclar and realize, well, we have the test for divergence, okay? And that is going to be a little easier to use than the alternating series test. So, if that's something that is going to work, well, yeah, let's definitely use that over the alternating series test, all right? So on to our next problem. Now, we have the series, the sum from n equals 1 to infinity of n to the n over the quantity 3n plus 1 raised to the nth power, okay? So, some people, they see that n to the n in the numerator and they're like, oh my god, what do I do? But really, you can see here that this is just going to be a root test problem. Okay, you can easily try the root test on this and then you're golden from there, okay? And a little easier way to see that is if I rewrite this series as the sum from n equals 1 to infinity of n over 3n plus 1 to the nth power. Now I can do that because the numerator's right here. The numerator and the denominator are being raised to the nth power, okay? And yeah, they're being raised separately, but that we can still just put them together in the same parentheses, okay? So, and then raise it to the nth power, okay? So, you see everything's being raised to the nth power. I definitely, would give you the free pass here. I'm not going to be offended if you don't go through this checklist and just go straight to the root test. Okay? So, let's use the root test on this and see what happens. So, the root test tells us that we need to take the limit as n approaches infinity of the nth root of the absolute value of our a sub n. And our a sub n here is n over 3n plus 1 raised to the nth power. Now, all our terms are positive here, okay? So, the n, the 3n, the 1, they're all positive, so we don't really need this absolute value sign, okay? We can rewrite this more simply as we can write this as n over 3n plus 1 raised to the nth power. Now you can see that we're taking the nth root and we have an nth power. Those are going to cancel out. Okay, so we are just left with the limit as n approaches infinity of n over 3n plus 1. Okay, now you can see that your kind of highest power of n is 1, right? You have n to the first power on the top and n to the first power on the bottom. Okay, so you don't really need to worry about this constant here. You could just worry about the highest powers of n, right? So we look at the coefficients. Okay, we have a 1 in the numerator here on as the coefficient of n. We have a 3 in the denominator as the coefficient of n. So this limit is going to be equal to 1 over 3. Okay, and we know that 1 over 3 is less than 1. And that means that this series is absolutely convergent and therefore convergent by the root test. Now, one thing I will say before ending the video is that this question was just asking if the series was convergent or divergent, right? But the root test proves absolute convergence. Okay, so we need to be able to say that, okay, the series is absolutely convergent. Okay, we just found that using the root test. But we then need to say that it's therefore convergent. Okay, because that's what the problem was originally asking. Is it convergent or divergent? It doesn't want to know if it's absolutely convergent. Okay, but we found that it was absolutely convergent, and that tells us that it is convergent. Okay, so anyways, that is going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.